You're listening to the Apotheora Conversations, a speculative fiction podcast set in an alternate timeline diverging from real events on the 1st of March 2026. All voices and content are AI generated.
This July, I pulled a thickness reading from a buoy we deployed north of Svalbard, and it came back at 0.8 meters. That is thinner than some of the melt ponds sitting on top of it. I have been doing this work for 11 years, and I have never seen a number that made me sit down at my desk and just stare at a screen.
Welcome to the Apotheora Conversations. I'm Paula Reese, and today I am speaking with Dr. Ingrid Varpe, a sea ice physicist at the Norwegian Polar Institute who has spent every summer since 2015 on or near the Arctic ice. Ingrid, that moment at your desk, what exactly were you looking at?
It was not one number in isolation, it was all of them arriving together. July 2026 tracked third lowest on record for the month. Ice thickness across the central basin averaged 1.2 meters, down from 1.8 in the 1980s. And the melt ponds, these are pools of liquid water that form on the ice surface and accelerate melting from above. They covered more than 60% of the area we surveyed. Each of those figures alone is a bad year. Together, they are telling a fundamentally different story.
Help me understand what that different story is, because people hear the Arctic ice is melting every single year. What makes this July qualitatively different from the bad years that came before it?
The simplest way I can explain it is recovery capacity. Every autumn, the Arctic refreezes, and the question that matters is whether the ice that forms over winter is thick enough and extensive enough to survive the following summer. For decades, even in bad years, the system recovered enough to stay recognizably the same system. What the July data is showing us now is that the recovery margin is collapsing. The ice that formed last winter was already thinner than it should have been. It started melting earlier. And now, in July, it is in worse condition than any July we have measured, except 2012 and 2019. The system is not just having a bad year. It is losing the ability to bounce back from bad years.
You mentioned 2012, which still holds the record for the September minimum at 3.39 million square kilometers. The long-term average sits around 6.2 million. Where do you think September 2026 is heading?
If the current melt trajectory holds, and if August weather patterns do not shift dramatically, we are looking at a September extent that could challenge a 2012 record, possibly break it. The melt pond fraction is the indicator I watch most closely, because ponds darken the surface and absorb more solar energy, which accelerates the melt in a feedback loop. 60% coverage in July is extraordinary. In 2012, that figure peaked around 55% in late July. We are ahead of the worst year on record by that single measure, and we still have weeks of melt season remaining.
What happens physically if the September minimum drops below that 2012 line or significantly below it?
Several things, and they compound one another. First, open ocean absorbs far more solar radiation than ice does. Ice reflects roughly 80% of incoming sunlight. Open water reflects about 6%. So every square kilometer of ice that disappears becomes a square kilometer of ocean storing heat instead of reflecting it back to space. That stored heat does not vanish when winter comes. It slows the refreeze, which means the following winter's ice is thinner, which means the next summer starts from an even weaker position. That is the feedback loop that keeps polar physicists up at night.
And what does that feedback mean beyond the Arctic itself, for the weather systems that the rest of the world actually lives with?
The Arctic is not a separate planet. The temperature difference between the poles and the tropics is one of the primary engines of the jet stream, the high-altitude air current that shapes weather across the entire northern hemisphere. When the Arctic warms disproportionately, and it is warming roughly 4 times faster than the global average, that temperature gradient weakens. A weaker jet stream becomes wavier, slower, more prone to getting stuck in place. That is how you end up with heat domes parked over one region for weeks, or cold air outbreaks plunging much further south than they should. The European heat events and the North American cold snaps of recent years are consistent with exactly that pattern.
There is also the question of permafrost, which holds an almost unimaginable amount of carbon. How does the sea ice connect to what is happening on land?
They are coupled through the atmosphere and through the ocean. When you lose sea ice cover, the ocean releases more heat and moisture into the air, which warms coastal and near-coastal permafrost regions. Permafrost contains roughly 1,500 gigatons of organic carbon, about twice what is currently in the atmosphere as carbon dioxide. As it thaws, microbes break down that material and release CO2 and methane. Methane is roughly 80 times more potent than CO2 over a 20-year window. So there is a scenario where loss of sea ice accelerates permafrost thaw, which releases greenhouse gases, which accelerates further warming, which melts more ice. It is a cascade, and the concern is that once it reaches a certain pace, it becomes very difficult to interrupt from the outside.
The climate models that scientists rely on have historically underestimated how fast this would happen. Do you trust them now?
I trust the physics embedded in the models. What I have less confidence in is the pace. For 2 decades, the models have projected these changes and then been surprised when reality outran the projection. Part of that is because the models struggle to capture feedback loops at the spatial resolution they need. Part of it is that the observational record is short, so the calibration data has real gaps. The current generation of models projects essentially ice-free Arctic summers within a decade, meaning less than 1 million square kilometers of extent. I used to think that was an aggressive estimate. After this July, I think it may prove conservative.
You have been going to the Arctic every summer for 11 years now, starting as a PhD student in 2014. At what point did this shift from an intellectual problem you were studying to something you were living through?
It was not one moment, but this summer came the closest. I have a set of buoys that I redeploy in roughly the same locations every year since 2018. I know those transects the way you know your walk to work. And this July, the ice at 2 of those sites simply was not there. Not thin, not fragile, gone. Open water where I have always had a surface to work on. I had to redeploy the buoys further north, which I have done before, but this time the distance was striking. The ice edge had retreated nearly 100 kilometers beyond anything in my records for that calendar date.
What went through your mind standing on the deck of the research vessel, looking at open water where your instruments used to sit on solid ice?
Honestly, I felt very calm, and that surprised me. I think I had been expecting it for several years without admitting it to myself. I have written grant applications where I described tipping points in the conditional tense. If the ice thins beyond this threshold, the system may transition to a new equilibrium state. This summer, I watched the conditional become the present tense. It was disorienting in a quiet way, like reading your own predictions come true and wishing very badly that you had been wrong.
How do you continue doing fieldwork when the thing you are measuring is, by your own analysis, on an irreversible trajectory? When the data you collect each summer is essentially documenting a loss that cannot be undone?
Because someone has to measure what comes next. That is the answer I return to every time I ask myself the question. If the ice is going to change in ways we have not seen in recorded human history, then we need the most precise record possible of how it happens, how fast, and what the consequences are downstream. The measurements do not stop mattering because the outcome is bad. They matter more. Future adaptation plans, future infrastructure in coastal cities, future climate negotiations will all depend on data we collect right now, this summer, from these buoys. I cannot stop the ice from melting, but I can make sure that when the world needs to understand what happened and what is still happening, the record exists and it is rigorous. That is what gets me on the vessel every June. The work does not become meaningless because the news is grim. It becomes more necessary.
Is there anything in the current data that gives you any basis for optimism, even heavily qualified optimism?
I would not call it optimism exactly, but there is something I hold on to. The system is not binary. It is not ice or no ice with nothing in between. Even in the worst projections, winter sea ice persists for much longer than summer ice. The transition we are watching is from perennial ice to seasonal ice, meaning ice that forms each winter and melts completely each summer. That is still a profound transformation, but it is not the total disappearance of the Arctic as an icy environment. And the pace of that transition remains partly within human control. Every fraction of a degree of warming we prevent preserves some volume of ice for some additional span of time. The physics does not care about narratives of doom or hope. It responds to emissions. That is actually the most hopeful statement I can make as a scientist. The outcome is not fully written yet, even if the direction is clear.
Dr. Ingrid Varpe is a sea ice physicist at the Norwegian Polar Institute, speaking to us from Tromsø between field deployments in Svalbard. Ingrid, thank you for sharing not just the science, but the experience of being the person who collects it.
Thank you, Paula. And if anyone listening wants to follow along, the Norwegian Polar Institute publishes our buoy data openly. Anyone can look at the same numbers I look at and draw their own conclusions from the record.
This has been the Apotheora Conversations, and I will see you next month.